How are you, everybody who is watching this fantastic learning and training multimedia documents? My name is Olenjolain. It's the first time to meet me. I would like to take this opportunity to welcome you into the process of learning the fundamental skills in electronics engineering, telecommunication engineering, electrical engineering, computer engineering, biomedical equipment engineering, and mechatronics engineering, or any field related to electrical engineering. So I would like to take this opportunity to welcome you and welcome some physical students who are pursuing ordinary diploma in electronics and telecommunication engineering at Dar es Salaam Institute of Technology. Firstly, I thank God who have given me a gift of teaching and a gift of being electronics and telecommunication engineer as a professional engineer. And I would like just to tell you that I'm going to combine the power of teaching and the power of engineering to make sure that I try my level best to teach you about this new technical language that's called electronics drawing. We had covered a lot of concepts in chapter 1. That's called Introduction to Electronics Drawing. And okay, we call just Introduction to Electronics Drawings. However, that we are responsible to touch about electronics drafting because as we discussed in previous session, we say electronics drafting is actual focusing on construction, manufacturing, and even implementation of that particular system. So I would like just to ask you to be serious, to have drawing tools such as a pencil, such as a ruler, and also sometimes you should have a papers and even exercise book. And a fresh mindset, then you have to get prepared to receive the new concept. Today we are going to discuss about lecture 4, about types of electronics drawings and electronics drafting. So we'll start with types of electronics drawing. There are so many types of electronics drawing and electronics drafting, but we will discuss the common types that actually are the fundamental or the beginner students. It's better to know them at the beginnings of their journey. So these contents have been prepared for any student or in any level, either A-level student, ordinary diploma student, undergraduate students, master degree students in electronics or in electrical engineering, electrical field, and even PhDs, because sometimes those PhD professionals, they need to quickly remind or to review about the fundamental concept they have been learning in different or in the previous levels. So I don't want to waste much of your time. I believe that you have a fresh mind, and let me appreciate there are some physical students who are in this class. And then I would like to ask you that make sure that you understand the concept that you are going to discuss. In case you have a question, don't hesitate to ask it. I have for the physical students, they just ask me directly, but for you, you just use the technology to ask questions. One thing which I want to tell you that get prepared to receive the new information that can help you to solve even small-scale, real-life electronics engineering problems. How are you, engineering students? How are you, engineering students?
We're fine.
I say this, the mic should be close to you. How are you, engineering students?
We are fine.
Well, so before we discuss, so they are fine. Are you ready for lecture 4?
Yes.
Well, so if you are ready for lecture 4, let us remind ourselves quickly or do the quick review of the previous lecture. The previous lecture was lecture number 3. First of all, what was the title of that lecture 3 of electronics drawing? Difference between what? Electronics drawing. So simply, in short, you can write difference between electronics drawing. Electronics drawing is vice what? Electronics what? Electronics drafting. Say electronics drafting.
Electronics drafting.
Okay, so what are the difference between electronics drawing and electronics drafting? Then our discussion began with what the meanings, what visual or graphical representation that we can obtain from electronics drawing. So what did he say in short? That electronics drawings can give you information about what? Electronics drawings give you information about what? Pardon? So this one is actual. Electronics drawings will teach you about how the components, how the electronics components and electrical components are interconnected, how they are interconnected, how they interconnected and work together to achieve the objective of that electronics system. Then we say that we have some examples of electronics drawing. The first one, it was block diagram. Say block diagram. So this block diagram, we say that is actual high level of what? High level diagrams that uses blocks and what? Block diagrams use blocks and what? Blocks represent what? Subsystem of that particular system. Arrows represent what? The flow of the signal from one point or from one block to another block, right? And then we discussed that. Another example, we discussed about schematic circuit diagram. Schematic circuit what? Schematic circuit diagram. So you say this is schematic circuit diagram is detailed. First of all, it is detailed diagram. So these detailed diagrams, it actually show the components. So show the connections of the components and also the values. So you'll see the difference between schematic diagrams and circuit diagrams that we are going to discuss today. Then another example is what? For the electronics, wiring diagram. So what is wiring diagram? So wiring diagrams we often use in assembly. In what? Assembly of electronic system. Right? In assembly of electronic yeah, so in most cases. But also you may have these wirings in case of electrical system. Then we discuss about examples of what? Of electronics electronics drafting. So in the examples of electronics drafting, we say, before examples, we explain the concepts of electronics drafting. Then we say that this is the diagram that give us details or teach us or actually that tell us about about how the system will be constructed, how the system will be constructed, constructed, how the system will be constructed and or implemented in the real world, implemented, and also how the system will be manufactured. In case of example, we discuss one example which is called detailed layout diagram, aka we just call it PCB layout. And in each example, we actually that once we discussed it, we support it with a particular diagram or is a particular figure. Okay? Okay, class? So then I left an assignment, or I would like just to ask you that to go and discuss about some other two examples of PCB layout. The first and the second one is called the component Components what? Components placement diagram. So, and then you have to support it with a diagram, or say a figure. Component placement. So component placement diagram. So the PCB layout or the detailed layout diagrams, you actually will be drawing your schematic circuit on the physical electronics board. And this second diagram, which is called the components, say components placement diagram. So this is a type of the diagram which actually that will be drawing the PCB board also and show the components how will be placed physically. Are we together? Yes. Then the third one is called what? Assembly what? Assembly drawing. So assembly drawings always will be the last drawings in designing a particular electronics or telecommunication system, because this one is actual. You are going to connect the components with wires that will be transferring signal from one point to another point. Are we together? So I left this one for you to discuss in detail about that. Then I ask you to do the 71, where you have to give 7 differences between electronics drawings and electronics drafting, and you have to support each drawing or each difference with a diagram. Okay? So I expect in your assignment to have, it will have 14 diagrams for 7 students in one group. So then let us now discuss, in case you missed something, you can review lecture 3, because you can access the goodness that we implement the technology in training and teaching. So now let us go to the lecture 4, the first lecture, and learn in detail about electronics drawing. Say types of electronics drawings and electronics drafting.
Types of electronics drawing and electronics
Again,
drafting.
say loudly with joy.
Types of electronics drawing and electronics drafting.
Again, say it.
Types of electronics drawing and electronics drafting.
So we say that in electronics, and in electronics, let's say that in electronics and it's a related fields, there are different types of electronics, different types of electronics drawings and the drafting. There are different types of electronics drawing and the drafting. So the following are common types of electronics drawing and the drafting. So the following are the common types of electronics drawings and drafting. So we are going to discuss almost the 7 types of electronics drawing and electronics drafting. So stay tuned. Then the first type of electronics drawing is called the block diagram. Class, say block diagram. Again, say block diagram. Again, say block diagram. So the first types of electronics drawings is called what? A block diagram. Say again, a block diagram. Yes, you can call your neighbor on your left hand side and right hand side a block diagram. So tell that your new name today with respect to electronics drawings is a block diagram. So just call Mr. or Madam or Miss Electronics diagram. So say Mr. a block diagram. Or Miss block diagram. Be careful on use of Mr. and Miss, okay? Yeah. So I said, in case of the songs, listen, stop writing. In case of the song, if you're analyzing a particular song, whether it's the national anthem, or maybe it's a particular song, so your favorite song, then block diagrams we can just see, how do we call it in case of the parts of the song? A chorus of the song, right? So in case that you're thinking about a song, then the block diagrams is going to be what? A chorus. So I ask your neighbor, how many choruses of the music do you know? Ask your neighbor, how many choruses of the music that do you know? Reply your neighbor's question. 1 or 3. So if that's the case, tell your neighbor, today we have another chorus that's called the block diagram. So what is block diagram? What is block diagram? However, that we have a topic that's called the block diagrams, but we are just introducing. A block diagram is a high level overview. So this is the high level overview of an electronic system, electronic system showing the main functional blocks, and how they interact and how they interact without detailing individual components. So this is the simple definition of a block diagram. A block diagram, we say that is a high-level overview or is a high-level diagram of an electronic system showing what? Showing the main functional blocks and how they interact without detailing individual components. Stop writing. 1, 2, 3. Read the definition of block diagram.
A block diagram is a high-level overview of an electronic system showing the main functional blocks and how they interact without detailing individual components.
So simply, the block diagrams uses what? The block diagrams use blocks and what? Blocks and what? Arrows to show or to represent the electronics or the electronics idea. So the limitation of the block diagrams, it does not show the components. Stop writing. So we say that in previous lecture I taught you an example of block diagram. So simply it just show the concept or the idea by using blocks and what? Arrow. We don't expect to see maybe a schematic symbol of resistor in block diagram. We don't expect to see a schematic symbol of the diode in a block diagram. We don't expect to see a schematic symbol of the transistor in a block diagram. Why? Because this is the high level. It's actually give you the big picture. It does not give you the details. Okay? But that big picture is very important for you to open the block diagrams to come up with a detailed diagram. Are we together? Are we together? Yes. Yeah. So that is, so the limitation of the block diagram is it does not show the details such as electronics components required to be used in that design. Electronics or electrical components that required to be used in that design. So the limitation of the block diagrams give us another types of diagram. So we need another type that actually will give us what we miss in the block diagram. Are we together? Are we together? Yes. So if that's the case, you say that is all about the block diagram. So example of block diagrams, example of this block diagram. So I will give you some few examples, and then the rest I will leave you to go and find. So example, we can have a block diagram of 40. So example, we said that a block diagram of linear power supply. So this is, we call it AC mains, and then we have the secondary block, and with this secondary block we call it step down transformer, and then we have another block. Make sure that you draw good rectangles, okay, good rectangles. Then this block we call it rectifier unit, then we have another block after rectifier unit, perform its function. Then you have the next block, which is called the filter unit, to filter the signal. And then we have another block, which we call it voltage regulator. So, or we call it regulator unit. And then we can have another block, and this block we call it loads. So this is, for this lecture, this is figure 1. So we call it the general block diagram, of linear, the detail. This is the detail. So the detailed block diagram of linear power supply. Stop writing. Put this there. Oh, it's nearby there. Okay. So listen. Stop writing. So this is another example. In last lecture, lecture 3, I gave you one example for general block diagrams, which actually was representing the general block diagrams of any electronics system, which they had 4 blocks. One block is called the power supply. The second one is called the input unit. The second one is called the control unit or system unit or brain of the system. And the first one was what? Output unit. You have to learn and you have to enjoy drawings, because that's the objective of this module. Okay? Okay? So then, this is another example. I'm giving you the second simplest and common example. So the name of this block diagram is called the detailed block diagrams of power supply. Say the detailed block diagrams of power supply. No, that's not the voice of more than 50 students. Say the detailed block diagrams of linear power supply.
The detailed diagram of linear power supply.
So in these block diagrams, you just see blocks. So these blocks are them as a subsystem of the entire system. I said it's operating, look and listen. Let me repeat, because some students are not listening. I say that we said in the block diagrams we'll be representing the idea by using blocks and arrows. And those blocks will be representing subsystem. This is a linear power supply system. Say system. System. Say system. System. Say system. System. For instance, I think that you know the digestive system or your biological digestive system, they are subsystem also. When you say subsystem, it means a small section or a small part of that system. Okay? So this is a small section of the linear power or subsystem of linear power supply system. This is the second subsystem of linear power supply system. This is the third subsystem of linear power supply system. This is the fourth subsystem of she noticed him. Of linear power supply system. This is a subsystem of linear power supply system, and this is another subsystem of linear power supply system. Would you like one of the car? Would you like to buy one? Okay, so with this system, then we have arrows. So arrows, they show the flow of the signal. That after this subsystem performs its function, then it delivers the output to this subsystem. And after this subsystem performs its function, delivers output to the next subsystem. Stand up. Okay? And also after this subsystem performs its function, it delivers the output to the next subsystem. And then after this subsystem performs its function, it delivers the output to another subsystem. And then after this subsystem performs its function, it delivers the output to this another subsystem. Then you have the overall block diagrams of linear power supply. Are we together? Yes. But you don't see any schematic symbol of resistor or inductor or capacitor or diode or op-amp or transistor or logic gates. Okay? Yes. Are we together? Yes. Yeah, so this is a good example. Then the second type of, have your seat, types of electronics drawings and the electronics drafting is called the schematic diagram. Schematic diagram. Say schematic diagram. Schematic diagram. Say schematic diagram. Schematic diagram. Again.
Schematic diagram.
Again.
Schematic diagram.
Okay. So what is it? Ask your neighbor, because we discussed this one. What is schematic diagram?
What is a schematic diagram?
Or your neighbor is no longer happy. Your neighbor is struggling on drawing the little block diagrams of 40 of linear power supply. So your neighbor is busy. So what is schematic diagram? That's the question that we have. Okay, so now let us discuss the second type of schematic circuit as schematic diagram. Say schematic diagram. Schematic diagram. Well, so a schematic diagram, we say that a schematic diagram is the most common type. Most common type is a most common type of electronics drawing of electronics drawing showing the electrical components, showing how the electrical and the electronics components are interconnected. Interconnected, showing how the electrical components are, electrical and electronics components are interconnected. Interconnected. How the electronics components are interconnected in the electronics, or to form electronics system. Form electronic system. So you say a schematic diagram is the most common. This is the most common type of electronics drawing showing how the electrical and electronics components are interconnected together to form the electronic system. To form electronic system. Then we say that it uses the standard schematic or schematic symbols. Standard schematic symbols. Example of this standard schematic symbol is the schematic symbol of the resistor. Then it uses the schematic symbol of the capacitor. Then it uses a schematic symbol of the inductor. Then it uses a schematic symbol of the diode. So whenever you see electronics diagrams in this style, hopefully that might be the schematic circuit. No, the schematic diagram. Say schematic diagram. Say schematic diagram.
Schematic diagram.
So the schematic diagrams so it gives the most simplified or abstract view, simplified or abstract view of the circuit, abstract view of the electronic circuit. Electronics circuit without focusing on the physical layout, without focusing on the physical layout. Who is talking? So we say that this one, okay, stop writing. Let us read the definition. 1, 2, 3, go.
Schematic diagram is the most common type of electronics drawing showing how electrical and electronics components are interconnected to form electronic system.
Electronic system. Then it uses what is standard schematic what is? It does not use blocks. That's the meaning. It doesn't use blocks and arrows. This one is actually using the schematic standard symbols and the wires. So and what is wires? The schematic standard symbols and the wires. So the example for a wire you will see something like this one. So listen, in block diagrams, the subsystems are represented by using what? Blocks. I say stop writing. In block diagrams, the subsystems of the particular system represented by using what? Blocks. And those blocks are interconnected by using what? Arrows. In schematic diagrams, the subsystem of the particular electronic system is represented by using what? Electronics components. Either one electronics or electrical components, or more than one electrical or electronics components. Then another key concept that in schematic diagrams, one subsystem is connected with another subsystem by using wire. Did you understand? Yes. Tell your neighbor, what did you understand? So the schematic diagrams is the most simplified. Say most simplified. If you have the fundamental of electronics and then you have been given an assignment to read and understand, the schematic diagrams is simple to understand that this is the resistor, this is the capacitor, this is the transistor, this is the maybe an op amp, and this is maybe an AND gate or the OR gate or the NOR gate. That's very important. So that's what we say that that gives the most simplified. But one of the limitations of, hello, I'm talking to you. One of the limitations of schematic diagrams, it actually does not talk about physical layout. Say physical layout. It doesn't give you any detail about physical layout. It just gives you the detail about how the system works in abstract level, in way of thinking, not in the way of how you can implement it. However, that it can give you some important information that can help you to develop or to design the physical layout. When you say physical layout, we mean about detailed layout diagram. So this one, it doesn't talk anything about how you will build or implement or construct that particular system. That's one of the limitations. But the second limitation says that schematic diagrams does not have or does not include the values of electronics components. So another limitation that, so you say another limitation of schematic diagram is it does not show the values of electronics and electronics components. So it doesn't show. So in most cases, it does not show. However, that some scholars confuse the difference between schematic diagram or schematic diagram and the circuit diagram. So let us have example of this schematic circuit diagram. So let us advance a little bit. So for this case, we have that VCC. So in VCC, we have a resistor. Then we have another resistor. Then for this case, we have a transistor. So this is VCC, this is collector resistor, and this one is emitter resistor, and this is R1, this is R2. So this is a simple example of schematic diagram of DC, we call it DC biasing amplifier. So you have to label it here. This is figure 2. The schematic diagram of DC biasing of the small signal amplifier. So listen, stop writing. Stop writing. These are the electronics components: resistor, 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 resistor. And this is the semiconductor device, which is called the transistor. Then this one we used to call it, this is collector terminal, and this is, we call it emitter terminal, and this is base terminal. So we can measure some voltages. If you measure voltage, here we have to measure voltage across base emitter, and here we have to measure voltage across collector emitter, and at this point you have to measure voltage across base collector. So listen, stand up, low, stand up. Listen, so for instance, R1 and the R2 represent a subsystem which we call the voltage divider. So R1 and R2, actually we deduced it from one block among the blocks that are used to represent that idea. I say stop writing. Stop writing. So R1 and R2 representing what? One block. So R1 and R2 formulate what? A subsystem. So this resistor 1, resistor 2 represent what? A particular system. Also RC, which is called the collector resistor. This one itself representing another subsystem. Then we have RE. So RE, this electronics component is representing a particular subsystem. It means we have a block for RE and they have a block for RC, because we always reduce schematic diagrams from the block diagrams, and especially detailed block diagram. Okay? So also this transistor, NPN bipolar junction transistor, is also representing a subsystem in that DC biasing small signal amplifier. But what can you notice? You just see that in figure 2 we have electronics components, and these electronics components are actually interconnected together by using wires, right? So you see that we use wires and schematic symbols of those electronics components. Another thing that you may note, we don't have values. For instance, we don't know the value of R1, we don't know the value of RC, we don't know the value of RE, we don't know the value of R2. In case we know the values, then this one we may call it schematic circuit diagram. But for that case, it's called the schematic diagram. Because we say one of its limitations, it doesn't show the values of electronics. Say values. For instance, we don't know that the resistance of R1 is 1K. It's not stated in the diagram. But remember that when we do for the physical implementation, we have to choose also the value of resistor, the value, and maybe the characteristics. We have to check also characteristics of the transistor. So each resistor has its resistance, but it's not shown in that schematic diagram. Are we together? Are we together? So you may see the difference between schematic diagram and the block what? You may see the difference between schematic diagram and block what? Here we use blocks to present the idea and the arrows. For this case, we are using electronics, schematic electronics, electronic schematic symbols, which we call the standard symbols, standard schematic symbols. But also use wires instead of arrows. But remember that there is a close relationship between schematic diagrams and block diagram. We always develop or design or deduce schematic diagram from detailed block diagram. However, that from the science, electronics and electrical science that you have been learning, you have just been discussing about the schematic diagram. That's all. You did not discuss about block diagram. And you don't know how do they relate. But in design, you cannot start from schematic diagram. You have to start always from the block diagrams, and then you deduce your schematic diagram from the block diagram that you have. Are we together? Are we together? Right. And draw quickly. Then another type. Do you have a question about schematic diagram? Do you have a question about schematic diagram? Do you have a question? Pardon? Can you speak loudly, Jackson?
I have not understand this. The first limitation of circuit diagram.
The first C? The first C example? Limitation, the first C limitation. Well, so Jackson is asking, he did not understand the first C limitations of the schematic diagram. In the first limitation, the schematic diagram does not talk about physical layout. Say physical layout. For instance, if you say that we are talking about, can I have your mobile phone? So this is the physical mobile phone. So the schematic circuit diagram does not talk about how will this mobile phone looks like physically. It just to show how the components within this mobile phone are interconnected. That's all. That's the limitation. So if you wanted to show the physical layout of this mobile phone, then you have to think about the types of electronics drafting. So you have to think about other diagrams rather than schematic diagram. Right? So the third type of diagrams is called the circuit diagram. Say circuit diagram. Class say circuit diagram. Again say circuit diagram.
Circuit diagram.
Again say circuit diagram.
Circuit diagram.
So what is circuit diagram? So what is circuit diagram? There's a close relationship between circuit diagram and schematic diagram. So you have to listen carefully. So we say that a circuit diagram, separating, a circuit diagram is often used interchangeably. It's often used interchangeably with a schematic diagram. So it's often used interchangeably with a schematic diagram. It means they have close meaning with schematic diagram. But the circuit diagram, may include the electronics components, and some additional details such as components, or such as values of electronics components. Values of electronics such as values of electronics
Component.
Restuta. What's going on? You are chatting nowadays. Your mobile phone is on top of your exercise book, of your table. What's going on? Aha, something is going on. Values of electronic circuit component. So separating. So what is circuit diagram? A circuit diagram is often used interchangeably with the schematic UT. With the schematic UT. But how can you differentiate circuit diagram from schematic diagram? It is simple. The circuit diagrams will always include the electronics components and some additional details. And these additional details you may not find in schematic diagram. You just find in circuit diagram. And these are additional details such as what? Values of electronic circuit component. Example of these values, example of electronics values that we are talking, electronics values are resistance, say resistance, say resistance, capacitance, not capacitor. Capacitor is electronics component. Capacitance, it's electric property. Resistor, it's electronics component. Resistance, it's electric property. Capacitance, another example of components values or electronics values. Example of electronics of values. Examples of values of 14 electronics components. Another example. Laplace. Components. Another example is what? Inductance. Another example for values of electronics component. Ampere. Ampere, we don't have electric property that called the ampere, we call it current. Current, sometimes it can show about voltage, and also it has to show about gain, say gain. Another electrical property is frequency. Sometimes you may see the values of frequency of maybe a signal generator of the particular system. And then another one, another parameter, power. Can show power. Another parameter, etc., etc., etc. So I said separating and then you are writing. Read the definition of circuit diagram. 1, 2, 3, go.
Circuit diagram is often used interchangeably with the schematic diagram. A circuit diagram may include the electronics components and some additional details, such as values of electronics components.
Example of values of electronics components.
Resistance, capacitance, inductance, current, voltage, gain, frequency, power.
Ask your neighbor, which one do you know among those examples of electrical properties? Which one do you know? So, separating and look on the blackboard. If we redraw this one or we transform this schematic diagram into, we can transform this schematic diagram into a circuit diagram. How? Look on the blackboard. We have the power supply, which we call VCC. And this one, we put its value, 12 volt. So now we are drawing what is a circuit diagram. Then we still have resistor connected to the collector of the transistor. And then this resistor, let's say it is 3.3 kilo ohm. So it has a value. I say it is stop drawing, stop writing, look on the blackboard. I'm transforming something which is very important. And you have to make sure that you understand. Then here we have RE. So the resistance connected to the emitter terminal of this transistor, let's say it is 2.22 kilo ohm. Then we have base of the transistor. Hello? Base of the transistor. Then we have to connect R1 to the power supply and the base of the transistor. So R1 for this case, suppose that the value of the resistance of R1 is 10 kilo ohm. 10 kilowatt ohm. Then we say that we have also R2. So this is R2. And we have ground. Make sure that you include always ground. Say ground. Say ground. So this is R2. So the value of R2, it is 2 kilo ohm. Then this is the transistor, NPN transistor. You may also include some values of the transistor, such as you can say that the base current is equal to 10 microampere. Not the base current, the collector current. Collector current for this transistor, according to the data sheet, collector currents of this transistor, according to the data sheet, it is 10 milliampere. That's important information. But also, you can find that another values about what VCA. Then it can be given a current gain. The current gain, the C current gains for this transistor, maybe we say that it's 1,000. So this is now we call it a circuit diagram or schematic circuit diagram. Why? Because the circuit diagrams uses electronics components to show subsystem and wires to show interconnection, right? But also it has some additional features, which is the values of electronics components that we have. Are we together? Yes. Are we together, class? Yes. So this is figure 2. So in this figure 3. So in figure 3, you may not see. Look here on the blackboard. Hello? Yes. This is the symbol of DC power supply, which we have just seen VCC. What does it mean? This is the voltage you are going to supply to the collector terminal of the transistor. That's why we call it VCC. VCC is abbreviations of voltage across collector. Stand up. Stand up. You stand up, yes. Voltage across collector. We don't know its value for this case of the schematic diagram, right? But its value should be defined when we are drawing the schematic circuit diagram. Then, Yaki, look here. This is the resistor. We just call the resistor 1, but we don't need its value. Stand up. Stand up. You. Okay? And then we have RC. This is just electronics components representing something. Then we have R2. Then we have RE. We know that these are the resistors. They must have resistance because that's why we are using them. But we are not interested with the values of those resistors and the power supply source or DC power supply, and also the values of some parameters of the transistor, because our intention, we just want to show the interconnections or how these electronics components and how these electronics components can represent different subsystems of this DC biasing of the small signal amplifier. When it's come for the circuit diagrams, we need some detail. And those details that when you draw, that is schematic, because circuit diagrams is just advancement of the schematic circuit diagram. Then we need to know what will be the power supply for our system. That's why we define it is 12 volts. It might be 12 volts, it might be 15 volts, it might be 9 volts, it might be 5 volts, depend to the design. Then what the values of these are 1, which you call the potential divider network. In this potential divider network, the value of resistance is 10 kilo ohm. And here 2 kilo ohm. Okay? And then what are the parameters of transistor? We need collector current, 10 milliampere, and we need also current gain, which is 1,000. Sometimes you may find even the name of the transistor. The names of the transistor, it might be maybe BC547. This is the name of the transistor. So you have a lot of detail. Then what the resistance connected in the emitter terminal of the NPN transistor. The value is 2.2 kilo ohm. What the values of resistance connect to the collector terminal of the transistor? The value is 3.3 kilo ohm. So once you have a circuit diagram, now you can go to the electronics shop, buy those electronics components, and build it. You can implement. But for the case of the schematic diagram, which actually that does not show the values of electronics components, you can't implement it because we have different types of resistors, we have different types of transistors. Which one are you going to use in your implementation? So it means that block diagrams is high level. Schematic diagrams give you some detail. Circuit diagrams give you too much detail for the implementation. Class, are we together? Yes. Sit down, those who have been standing. So this is figure 3. We call it, you may either call it a circuit diagram or schematic circuit diagram. So you have to know the difference between schematic diagram and circuit diagram. But also there's another terminology which is combinations of the two. Schematic circuit diagram. So you have the components and its values. So simply, according to the subject, this you can call it is the circuit. This is the what? The circuit diagram. The circuit diagram of what? Of DC what? Biasing. DC biasing of small signal amplifier. Jackson, stand up. And you have to note this symbol, this one. So this is schematic symbol like this. We call it a ground in electronics. Say ground. Say ground. In case of the batteries or in case of the system, we call it negative terminal. So the negative terminal, or where we connected the components to the negative of the power supply, that we call it ground. Say ground. We don't mean about the soil. No, that's the electronics ground. And if you don't have common grounds in electronic system, the system will never work. Tell your neighbor, we are learning electronics drawing. A question about the circuit diagram and schematic diagram. If you have a question, ask. Schematic circuit diagram. This is the schematic circuit diagram. First of all, it is schematic, but also it has values. So we call it schematic circuit diagram. Or we call it a circuit diagram. Jackson, you have been slumbering. We wrote from the definition. A circuit diagram is often used interchangeably. We see what is schematic diagram. It means sometimes some of the scholars, some of the scholars may call this circuit diagram, or may call this a schematic diagram, or may call this a schematic circuit diagram. But what the difference? In schematic, the clear difference, in schematic diagram, we just have the electronics components with all the values. In circuit diagrams, or schematic circuit diagrams, we have to add the values of electronics components used in that network. I want to add another type, but the way you seem that you are saturated. Say saturated. Do you remember saturation? Where did you learn saturation? In which subject? Biology. Chemistry. Okay, so let us finish with the first type of electronics diagram. And this is very important. It's called the functional block diagram. So it has the mathematical terminology called the function. Do you remember the topic of function? Ask your neighbor, were you competent in function? So what did you cover in function as the second topic of basic mathematics from 3? While the first one is called relation. So what did you cover in function? Inverse of the function. Pictorial representation of the function. And in these diagrams, in terms of electronic drafting, we have also pictorial diagram. Pictorial that we introduced you in range, in relation and the function. Do you see the goodness of mathematics in engineering? Say functional block diagram. Again. Again. Nini? Pardon?
Functional block
Eh?
diagram.
Say functional block diagram.
Functional block diagram.
Uh-huh. So what is functional block diagram? So you say that a functional block diagram, we say that the electronics diagram that shows the function of each part of the circuit or system, okay, of the circuit or system, by illustrating the various function or stages, stages of a circuit, stages of the circuit, as blocks with arrows showing signal flow, flow. So a functional block diagram, say again, a functional block diagram. This is the type of electronics diagram that shows the function of each part of the circuit or system by illustrating various function or stages of the circuit as blocks with arrows showing the signal flow. Read it. 1, 2, 3. Reinforced understanding. Have your seat. What is functional block diagram? No. What is functional block diagram?
Is the electronics of the circuit or system by illustrating the
So you have to know the difference between functional block diagram and the block diagram. So the functional block diagrams is actually show functions of subsystem in that particular system, while the block diagram shows the interconnection between electronics components and how those components will be processing the electric signal as it flows from one block or from one component to another component. Okay? So in case of the functional block diagrams, it means we can take electronic circuit or electronic system and break down according to the function. Say according to the function.
according to the function.
So it means that we can break down the big maybe electronic circuit and break down into different sections according to what function does that part perform. Are we together? And that's why that we have functional block diagram. Also it uses blocks and what? Arrows. Blocks represent what? A subsystem. And that subsystem actual should perform a particular function in that electronic circuit. Are we together?
Yes.
And then so if you have another block, that block will perform a particular function. If you have another block, that block will perform another function. And then if you integrate all the function performed by each blocks, or performed by each functional blocks, then you can have the performance of the entire system. Class, are we together? We often use, or we often find, or we often use functional block diagrams, especially in the electronics data sheet. So electronics data sheet. If you have been taught about resistor, everything about resistor, one of the important information, you should know also about data sheet of a resistor. If you've been taught about a capacitor, maybe in basic electronics, another important part, you should be taught about the data sheet of capacitors. If you've been taught about inductor or maybe a diode, you have also to be taught about how to read their data sheet, because we call data sheet, it's the manufacturer's mind. You are not the one who made that resistor, you're not the one who made that diode, you're not the one who made that transistor. Somebody has made it for you. So once it has been made, it has to be, means the manufacturer of that electronics components must also write a technical sheet that's called the data sheet. So in the data sheets of sensors, for instance, you will find the functional block diagram, especially if you have a complicated system, which actually cannot draw its block diagram. You may use functional block diagrams to explain the function of the different parts. Okay? Okay? Yeah, so you have to note this one. So you say that the functional block diagram is often used in electronics data sheets to represent the function, or to represent different functions of electronics component, or electronics device. So this is the homework. This is homework 4. So the homework 4 is actual. Draw the clear functional block diagram of accelerometer sensor. So this is the sign. Draw the clear functional block diagram of accelerometer sensor. Say accelerometer sensor. Say accelerometer sensor. So accelerometer sensor is very, stop writing. Accelerometer sensor is very important sensor in electronics industry. It's a sensor which actually can give the accelerations in 3 dimensions. In x-axis, y-axis, and z-axis. And I want to tell you that this accelerometer, it is used in our modern mobile phones, such as smartphone or iPhone. Take your smartphone or iPhone. Take your smartphone or iPhone that you have. Features mobile phone of Sosado, they don't have it. So once you take it, play one video that you like. Play your most favorite video. Play your most favorite video. And then if you play that that favorite video of yours, then we ask you to align your mobile phone in particular structure. In particular structure. For instance, this is one of my favorite video. So you could define that this is one of the axes. Okay? Listen, hey! This is one of the axes. So the people will be standing in this style. If now I align this mobile phone in this style, then the video also will align according to which is the vertical axis. Right? That's the function of accelerometer. If it does not have accelerometer, when I align my mobile phone, then the music is still standing in this direction. Okay? So then, if now I align this style, this is another axis. This is the steady axis. Then you find the video also turn. Right? That's the function of 40 accelerometer. If you align in this style, also the video align in another or the direction. So that's the function of accelerometer. If your mobile phone does not have accelerometer, you won't experience such kind of the features. Is it clear? Is it clear? Yeah, so you have to go and find its functional diagram so that all the students will come with a single response. That's why I gave you a specific functional block diagram. Class, did you understand? Hey, stop your music now. Have you understood? Yes. Eh? Yes. Ask you a question about functional block diagram. Ask a question about functional block diagram. So can you find this functional block diagram? Because the end of the class, you say yes. Because always as Tanzanian, we accept these things which you have to present in future. So if that's the case, this is the end of lecture 4. I would like to welcome in lecture 5, where actually be discussing about types of electronics drafting. And I thank God who have given me a special anointing to teach you about this concept. I believe that you'll not claim it. You have understood, you have enjoyed it, isn't it?
Yes.
Ask your neighbor, did you enjoy lecture 4?
Did you enjoy lecture 4?
Ask your neighbor, did you enjoy lecture 4?
Did you enjoy lecture 4?
Yes, I did.
Yes,
okay, so maybe you still have some questions. You have to make sure that you review the contents as well as you can, but make sure that you do the assignment and try to find some more examples in order for you to understand and to be familiar with them. So if that's the case, I would like to say thank you. I thank God who have given me this chance to teach you. Welcome in lecture 5 to enjoy about electronics drawing, and tell your neighbor we still have a lot of good news in electronics drawing. Stay connected. Tell your neighbor. Tell your neighbor we still have good news about electronics drawing. Stay connected.
We have good news.
Did you understand?
Yes.
Yeah, so it's time for me to appreciate you. You have done a good work. You have been facing a resistance of slumbering. Say slumbering.
Slumbering.
Yes, number of students have been slumbering. So 1, 2, 3. Hongera. Imara kwa kuelewa. Wow, thank you very much.
Thank you.
Finish the writing and then move.
Africa.